So in the previous lesson, we talked about relations, and now we're going to talk about the domain and the range of relations. So just to recall, a relation indicates the association between elements of one group of objects, that'd be your input set, with the corresponding elements of another group of objects in the output set. The set of all possible inputs is called the domain. The set of all possible outputs is called the range. So in this case, with this arrow diagram, which we saw in the previous class, the domain is all the possible inputs. So apples, bananas, oranges, raspberries, tangerines. The range is just the set of the outputs, all the possibilities there. Blue, green, orange, red, yellow. And if we're talking about discrete data, like the arrow diagram, which would include relations listed as ordered pairs, arrow diagrams, like we mentioned, table of values, or graphs with only points on it, not a line drawn through the points, but just graphs with points on it, the domain and range is going to be listed in numerical or alphabetical order within a set of braces, and braces are just curly brackets. So if I was to list the domain and range for that relation in the arrow diagram, I would just list all those elements in alphabetical order, and I do it within the braces, within the curly brackets. For the range, the same thing. Alphabetical order within a set of braces. Now, what exactly is discrete data? It's best to look at discrete data or explain discrete data by looking at a graph. Graphs with only points on it are examples of discrete data. Graphs with lines through it are called continuous data. What's the difference? On the left here, we have goals scored per game. Whatever game it is, say it's hockey, right? And you can see that in Game 1 here, there were 8 goals scored. Game 2, there were 12 goals scored. Game 0, I guess that's your starting game, 4 goals scored. But it's discrete data. There's no line drawn through here because, well, you can't score half a goal in a game, right? You can't score 8.5 goals. You can't score 9.5 goals. You either score 8 goals, 9 goals, or 10 goals, right? So that's discrete. Values between points are not possible. The example on the right shows the growth of a tree. This is in meters, and this is your time. And here, this is an example of continuous data because, well, a tree can't just jump from a height of 2.2 meters up to a height of 2.3 meters. It must grow from 2.2001 to 2.2002 to 2.2003, etc. It must grow gradually until it hits 2.3 meters. It can't just jump from 2.2 to 2.3. Really, there's an infinite number, a never-ending number of values between those 2 points. So discrete is just points, no lines. Continuous would be lines through the points, saying that there's an infinite number of values between those points. Okay, let's look at an ordered pairs example and an arrow diagram example with just numbers. We're going to determine the domain and range of each of those examples. Now, when you look at ordered pairs, remember the domain is the left side. It's the input variables. It's your independent variables. It's in the pair of numbers, it's the one on the left. So you have the number 1, 0, 3, -3, and 5. That's your domain. But when you list it, domain, we list it within the braces, the curly brackets, and we have to list it in numerical order from least to greatest. So -3 is the smallest number, and then 0, and then 1, and then 3, and then 5. So that's my domain, all the possibilities of that input variable. For the range is going to be your dependent variable, the output, the right side. So the range we'll list in curly brackets again, and it's going to be your 2, 5, 8, 2, and 9. 2 is shown twice, but we only have to list it once when we list out our range, and again, we do it in numerical order. From least to greatest, that'd be 2, 5, 8, and then 9. So that's your domain, all the possibilities of your input variable. That's the range, all the possibilities of your output variable. Looking at the arrow diagram example, your input is on the left side again, your output's on the right, so your domain is going to be all of that. The range is going to be all of that. When we list it, we put in curly brackets, order from least to greatest, 1, 2, 3, and 4. And the range, same thing. In those braces, -2, 3, and 6. And that's it. Next example, table of values. Table of values, we know that the input variable is your x, that's on the left side, so the domain is going to be all of that. And the range is the output variable, so all the possibilities of y. And when we list it, again we're going to list in numerical order from least to greatest within a set of braces. -9, -7, 0, and 3. For the range, are all the possibilities of the y variable. That'd be 1, 3, and 5. We don't need to list 3 twice because the range is all the possibilities. You can have many 3s but when you for y, but when you list the range, you only list that number once. Now looking at a discrete graph, so a graph with just points on it. Right, we have a point here, 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 and here. Now remember what the domain and range is. The domain is all the x values, the range is all the y values. The x values tell you how far along you are on the x-axis. The y values tell you how far along you are on the y-axis. So if we're looking at our domain and range here, we're going to list all the possible x values. So let's do that. For this point, I'm going from left to right. For the first point, the x value is -1. For the next 2 points, over here and over here, they have the same x value, right? An x value of 0. For the next point, where does that lie along the x-axis? It lies along 4. And the last x value has an x value of 5. Or the last point has an x value of 5. Now when we list the range, we go from numerical order, least to greatest, so we're looking from down to up. So going from down and looking up, our first y value comes from this point, and that's a y value of 0. Down to up, our second point is this guy, and that has a y value of 1. Going up again, the next one has a y value of 1, 2. We go up again, we have a y value of 1, 2, 3. And then going up to the last point, we have a y value of 6. So that would be your domain and range for that example with graphing. For continuous data, or graphs with lines or curves on them, we are going to be describing the domain and range with very specific notation. So the domain is going to look like that. The range is going to look like that. Now what does everything mean here? Well, the D and the R obviously mean domain and range. We know those curly brackets or the braces are called braces, and those mean the set of. The bar on the next to the X and the Y on the left side, that bar means such that. The E that you see with XER and YER means an element is an element of or belongs to, and the R with two lines means the set of real numbers. So putting that all together for domain, we can say, well, the domain is all the x's, or is the set of x's such that, we'll describe the x's somehow, and all those x's are elements of the set of real numbers. Okay, so let's take a look how that's all going to work when we look at graphs. A few notes to begin. When looking to describe the domain, the x values, scan the graph from left to right. Left to right. When looking to describe y values for the range, scan the graph from the bottom to the top. Why do we go left to right, bottom to top? Because we always list the domain and range from the smallest number to the biggest number, the minimum to the maximum. If you see arrows on a graph, that means that graph goes on forever in that direction. It's infinite. We'll use this form to describe the x and y values. So it just means, in this case, x is greater or equal to the minimum value, but less than or equal to the maximum value. And same with the y. Y is greater than or equal to the minimum value, and less than or equal to the maximum value. But if the graph is going to have arrows, we're going to have to adjust that description, and I'm going to show you how. So let's look at determining the domain and range for this continuous graph over here. How do we know it's continuous? Well, because it's got lines, therefore it's continuous. Okay, what we're going to do is describe the domain and range using this format. And again, when you're looking for domain, you're scanning from left to right. So you look to the graph from the left side all the way to the right till you hit the first x value. That's your minimum x value, right over there. So we can say domain in the braces is x value such that x is going to be greater than the minimum. So we have an x here that's going to be greater than the minimum value that you hit, which is a -5. And then you scan all the way, continuing from left to right until you hit the maximum x value, which is a +5. So your maximum is a +5. You have your minimum, the variable x, your maximum, and then point your arrows to the left. Right there, you've said that x is greater or equal to -5, but less than or equal to +5. Okay, and then the last step is, these are all real numbers. So we say x belongs to the set of all real numbers, just an R with two lines on it, and then close your brace. Okay, now for the range, you do the same thing, minimum to maximum to describe it, and to look at minimum and maximum values for the range, you go from the bottom to the top of the graph. Okay, so scanning from bottom to the top, your first values on the bottom hit the x-axis there, that's a y value of 0. So your range in the braces is y such that y is going to be greater or equal to the minimum value of 0. It's going to be less than or equal to the maximum value. For the maximum value, again, we scan the graph from the bottom all the way till we reach the top of the graph, till it hits a maximum y value of 5. And then we say, hey, y belongs to the set of all real numbers. And that's it. That's domain and range for a continuous graph. Let's look at a similar example, but this time there's some arrows involved. We'll see how that changes things. Okay, so we have a graph that looks pretty similar, except it's got arrows, but we'll go about this the same way and make some adjustments at the end. Now looking at the domain, we have our domain x such that, and we're going to go for minimum to maximum values in the domain. So we scan from left to right, and even though it looks like the graph, it'll start with an x value of -7, that arrow says it goes on forever. You know, it goes on forever, it gets smaller and smaller and smaller. We can say it goes on to -infinity. -infinity. Whoa. The sideways 8 is infinity. So it goes on forever in this direction, and it goes on forever downwards too. So x is going to be greater than that. And then same thing, scanning from left to right. There's not really a maximum value for x because that graph keeps getting bigger and bigger. It's heading towards a maximum value of infinity. And let me just complete this here. When that happens, you're saying, in this case, x is greater than -infinity, but less than or equal to +infinity. Well, basically you're saying x is everything. X goes on from the smallest ever possible number to the biggest ever possible number, so you don't even need to write any of that part. You can just leave your domain like this. For the x's, x is any of those real numbers. So we can just say domain is x is all, or is all the real numbers. That's it. That would be your domain. Now let's look at the range, because we're going to do pretty much the same thing. We have our range. Now, what's the minimum value of the range? We look from the bottom to the top. Well, that graph keeps going downwards, right? It keeps going downwards, so there's really no minimum. Your minimum would be like -infinity. You have your y. Arrows are always pointing to the left. And then we go up all the way to the top, the maximum value. Over here, maximum value would be a y of 5. And then we have our y as a part of, or belongs to the set of all real numbers. Now notice we crossed out the infinities part with the x's. We can do the same for the y's. Just cross out this infinity part. So for here, to clean it up, we can just write y is less than or equal to 5, and then y is in the set or belongs to the set of all real numbers. But for the description part, you don't need to list any of the infinity things. You can just cross those out. Let's take a look at this example. Pretty similar to that triangle. So see if you can do it on your own. For the domain, if I'm describing my x's, I put the arrows pointing to the left, and I'm looking for a minimum and maximum value. So scan from left to right, and I notice for the minimum and for the maximum, those arrows keep moving. Even though it looks like it's going downwards and to the left. So for the x's, it's going to the -infinity. And for the x's on the right side, those are also going to infinity, +infinity. They're just, those arrows go on forever. So your minimum value is the -infinity. The positive value is the +infinity. And we know that we don't need to write those infinities. So we can just leave this as domain is the set of all real numbers. For the range, well, those arrows point all the way downwards forever. The minimum value for y is -infinity. Let me write that more clearly. -infinity. You have the arrows pointing to the left. You have the y going up to a maximum point of 5. And y belongs to the set of all real numbers. Now, remember when we have the infinities, we don't need to write them, so we can just get rid of all of that part. So we have our range of just the description being y is less than or equal to 5. Okay. Domain. Look from left to the right. Well, look, those arrows point forever. They're going forever to the left and forever to the right. So that domain is covering everything. X is all those real numbers. For the y, for the ranges, I'm going to be a bit more explicit. We are going to have our y, we're going to have our arrows, and we're going to go for the minimum to maximum values. The minimum value from bottom to the top, that would be a -6. And the maximum value, well, you see that graph is going to go forever upwards. So the maximum value would be infinity. Okay, so in this case, again, we don't need to write the infinity, so we'll cross that out, and you'll be left with r, y, and then -6 with the arrow to the left, and then the y. So y is greater than or equal to -6. But in this part, this description, when you only have one arrow, you want to list the variable first. So you don't want to say that -6 is less than or equal to y. What you want to write is y is greater or equal to -6. Notice in both cases that open side is right next to the y. So your range would be described as such. The only thing we changed here was when you have just one arrow, not two arrows, just one arrow, write the variable first. So we wrote y is greater or equal to -6 rather than -6 is less than or equal to y. Okay? Let's look at some other examples. Okay, here. Now, if you notice scanning from the left to the right for your domain, that the arrows are going to go to the left forever and are going to go to the right forever. And when you scan from bottom to top, well, the arrow goes down forever and it's going to go up forever. So it's covering everything. So the domain then is just all the real numbers being covered. And the range, all your possibilities for y is everything, all real numbers. How about this circle? Looking from left to right, our minimum x value is -5. Goes all the way up to a +3. So when writing the domain, I have x such that the minimum value is -5. We have our arrows point to the left. The maximum value is a +3. And x belongs to the set of all real numbers. For y, we go from bottom to top. So the minimum value for y is -2. The maximum value for y is a +6. So the range is y such that you're going from a minimum of -2, arrows point to the left, up to +6, and y belongs to the set of all real numbers. For this, just one line, think about what you would write for the domain and range. For domain, that's a list of all possible x values. If we scan from left to right, we see an arrow saying the graph goes all the way on forever to -infinity. And if we scan all the way for a maximum value, that arrow keeps going down to a positive infinity. So all real numbers are covered for the domain. Now for the y, the minimum value for y is 4, but the maximum value for y is also 4. So y is just equal to 4. So for your range, you would just write y is equal to 4. And that's it. And last example now, we have this zigzag of a graph, but we deal with it the same way. We're going to have our domain being our x values such that, and we're going from a minimum to a maximum value. So the minimum value scanning from left to right is a -5. Arrow points to the left. And we scan all the way from left to right to the maximum value, which would be a +5. So minimum value is -5 on the x-axis, +5 on the x-axis, and x belongs to the set of all real numbers. And for the range, we scan from bottom to top. Range are your y variables such that, and we describe from bottom to top, minimum value of -6. Arrow points to the left, to the maximum value of a +6, and y also belongs to the set of all real numbers. Looks like we have one more example actually. This graph. Now, before you jump right into it, notice this graph doesn't have lines. So this is actually a discrete graph. And with discrete graphs, what do? We just list the numbers from least to greatest. So for the domain, we're going to list all those x values from least to greatest. So we'll start here for the least. That's a -5. The next point is at -4. Then you have -3, -2, -1, 0, 1, 2, 3, 4, 5. Those are all your possible x values. And we just list them from least to greatest. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and close the braces. For the range, you do the same thing for the y values. And to look for minimum, you just go from bottom to top. So the y value here is 0, the y value here is 1, y value here is 2, y value is 3, 4, and a y value of 5. Those are all your possibilities. So we have 0, 1, 2, 3, 4, and 5. It's the same on the left and right, so we don't need to repeat anything. Okay, so I'm going to give you a worksheet with some practice on this. Please, because this is a bit of a different kind of abstract thing, please join the tutorials on Tuesdays and Thursdays and ask me any questions if you need a hand. Thanks.